Hello everyone, Eric here, and welcome back to my computational science video tutorial. Today we're going to be looking at creating functions in C++. Now I do want to start, and I don't know if my mic will pick it up. There is construction in my building, so if you hear kind of a grinding sound, that's what that might be. Alright, we're going to get started here, and you can see I have CLion that I'm using for my C code, and this is a default program that CLion puts together. I'm just going to get rid of this. We don't need this hello world. And in fact, in modern C++ and C++ 11, when I say that, I mean the C++ 11 standard, we don't even need the return 0. So we can have an empty main functions. And in fact, we already have our first function here. Int main is a function. Now in C++, we do have to put our functions before we use them. So we're going to be using our functions in the main function. So I'm going to start my function before. When we're creating a function, we have to follow something called a function template. And a template is just kind of going to tell us, hey, this is the style for how we write our functions. So I'm going to create a function that's not going to return anything. And when you don't return anything, we're going to say that it's going to return void. Void is a way of saying nothing. And I'm just going to write a function to print a line. It's actually going to be a line just full of asterisks. I often use those to kind of separate things being printed on my screen. So I'm just going to create a function. I'm going to name my function print, print stars is what I'm going to call it. Now the input for this is also going to be nothing. So for no input, we can just write an empty set of parentheses. That means we're not putting anything in. You can also write void here, but we don't need to. Now I'm just going to define the function right here. So I'm going to put an open parenthesis, and you can see that CLion automatically matches it with a closing parenthesis. I do kind of like having a space there just to make things look nice. And we're going to print something to the screen. We're going to C out, and I just want to print out 10 stars. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Alright, so every time I want to print stars to the screen, I can now just call my function. And to call the function, you just start typing the name. So print stars. My computer must be thinking. It'll normally complete that kind of thing. So now when I run my function, it's going to print stars to the screen. So if I click the green button, it's going to compile, it's going to build, and it's going to run the function. Now in CLion, the first time you run a function, you do need to tell it what your executable is. I named my project CPP, so the executable is just called CPP. All right. So it's building the project right now using CMake, and this will take just a moment. So here we're creating a void function, and we're running our program with it. And we're going to be adding a couple more interesting functions to show what C++ can do. All right, now that the function is done running, you can see here it prints these stars. So the next thing I might want to write is I might want to write a function to find the area of a triangle. So for this one, we have to think about what kind of input and output we want. So for the area of the triangle, we have to think, what is the input? Now the input is going to be the base and the height. And the output is going to be the area. So these are numbers, and we want the numbers to be floating point numbers. And the floating point numbers we like to use are double precision. In computational science, I always use double precision unless I have a very specific reason not to. So my function is going to return a number, and that number is going to be a double. And I'm going to call this area of triangle, and it's going to have an input of base and height. Now you might notice if you're watching my other videos, in Python, I write all lowercase and I separate with an underscore. But in C++, we often use a capital letter for the first, for the first letter of each word. We capitalize it. It's just different programming styles for different languages. In fact, up here where I have print stars, I kind of did that in Python style. In C++, I maybe should have done it print stars. Now if I change it up there, I do have to change it down here. All right, everything should be working. All right, so we're going to write a function to create or to find the area of a triangle. We're going to give it 2 input. Now the 2 inputs are going to be the base and the height. in my input, I have to tell it the type of input. So the base is going to be a double, and height is going to be a double. And this is how we specify it. We write the word double followed by base, and the word double followed by height. So the two parameters that are going into the function are double precision floating point numbers, and it's expecting an output of a double precision floating point number. So I can create a new variable. I don't really need to put double here. I can just say auto area equals base times height. Actually, this is a triangle, not a square, so I'm going to go 0.5 times base times height. And what this is going to do is it's going to automatically figure out what the area is going to be. And this will actually be useful a little later. I'll show you kind of how that works. Now I'm going to return area. So we compute the area and we return it. One of the reasons I really like the auto initialization of variables, if I want to copy this and if I want it to work for non-doubles like a float, I can actually create kind of a version of this program, and I just need to change the template in this first line, and the second, and all the internal code stays exactly the same. So with this copying and pasting of code, you can see that this auto initialization reduced the number of errors that I might have to fix later. So it's a very powerful thing that we have in the modern C++. Unfortunately, it only works in C++ 11, and I have encountered a few machines that are kind of old and aren't up to, they're not up to date with the current standards. All right, so we've created our functions, area of a triangle, and we want to use these functions now. So what I'm going to do is I'm going to print the result of this to the screen. So we're going to see out the area of a triangle is, and then we have to put in area of triangle. Now, I haven't typed it yet. I'm waiting for the autocomplete to pop up. The nice thing about autocomplete is it does simplify typing this in. And we do have to be a little careful when we put the input in. We need to make sure we put our input in as a double or a float. Because we've defined this function two different ways, if I just say something like 8 and 10, what's happening here is I'm putting my input value in as integers, because 8 and 10 are simply integers. Now if I put 8.0 and 10.0, now the input is double precision. If we put the F at the end, then it's determined as a single precision floating point number. So we have to choose which input value we're using for our area of triangle function. I'm just going to do it 8.0 and 10.0. Otherwise, we could just delete this redundant function because the functions do the same thing. It's not really that necessary. All right, so we're going to put this function in. I'm also going to print stars again. Thank you, autocomplete, saving me some typing. We are just quickly going to build this with CLion. It usually doesn't take too long, but building can be slow. I know a lot of people like Python because you don't have to go through the build phase and the compiling, and compiling is slow. However, once you have your running program for larger projects, it's much quicker to use a compiled library. All right, so you can see here we are printing the stars. Then we say the area of the triangle is 40, and then we print our stars again. All right, so we can see here just some of the basics of how a function works. And I think with a lot of these, function creations, how we create our functions is very straightforward. We always say the type of output, and if we don't have any output, we say void. Sorry, I saw the word star and got confused. So we have to tell it what kind of output we're going to have, or what we're going to return. And then inside the parentheses, we have to tell it the type for each input. And this creates what we call a function template. And based on the function template we give it here, it'll tell us the output. So here for area of triangles, let's say for floating point input, what if we don't want to put the 0.5 there? Let's say it's different for some reason. If we copy this code, and if we put an F here, even though we have two inputs that look exactly the same, when we put the F there, what's going to happen is when the function is built, we're going to have... All right, so when the function is built, what we're going to have is two different outputs. When it runs, the double precision is going to output 40 and the single precision is going to output 80. So you can see here, for the area of a triangle, because we have different code, the signature for the input changed, and because of this changing signature, we actually get different output because the decision we decided to do changed with the type of input that we have. So sometimes this is important. We might want to do something different for integers than floating point numbers, because integers, we want integer output, so there's going to be rounding and things like that. All right, well, that's it for this. I hope it's been useful. Thank you for your time, and keep on coding.